Shall we start this session? Can you hear me, guys? I hope it's audible. Let us start this session. Since we are solving problems on rectifiers, so in the last class, we saw a question. In that question, they were asked us to calculate the voltage regulation. How many of you did that question? If you figure out any answer, do let me know. What is the voltage regulation for the given rectifier circuit? Anybody? Just drop your answer in the comment section. Chalo. If you found the answer, just do let me know in the comment section. What is the question that we saw? I hope this is the question, right? A 6-pulse thyristor converter is connected to a supply through the transformer of 6% reactance. If secondary voltage RMS voltage is 440, then what is the expected voltage regulation? And the constant current is given as, that is constant output current is given as 150 ampere. Any rough idea for this question? Like what can be the expected answer for this question? Sir, we did in this way, we got this answer. Like any ideas? It's a direct formula, right? Some of you might knowing this. Usually when the moment our three-phase system is connected with the transformer via transformer, in between our supply and the transformer we will be keeping in between our rectifier and the transformer we will be keeping, I am writing here, in between supply and our rectifier circuit we used to keep a transformer in order to step down the voltage. Your rectifier demanded voltage might be different from the supply voltage. In under this situation, transformer will be helping us to step down the voltage. Okay, sir. Now everything is given here. And the transformer is a 6-pulse transformer, and its reactance also given. I'll be directly giving the formula. I cannot derive everything here. It's I already told you. So I'm giving the formula. Just to remember. Whenever they are asking 6-pulse means, first of all, it is what? Full bridge thyristor. 3-phase the full bridge converter. Why? Because I told you 3-pulse only will be considered as what? Half-wave rectifier. 3-phase half-wave rectifier will produce only 3 pulse within 360 degree. If you are receiving 6 pulse or 12 pulse in the output side, then that will be considered. Then that is what? This is 3 pulse full bridge rectifier. So I can confirm that from this 6 pulse means it is denoting 3-phase full bridge rectifier. First conclusion. And the second conclusion, let me drop the formula to calculate the voltage regulation. Whenever they are talking about the transformer with the rectifier circuit, to calculate the voltage regulation, we have the derivation. I'm just dropping the answer. So it will be equal to 2 times of omega ls. 1 minute. Yes, it will not come. This 2 is for another one. Just keep omega ls. This is, we just want voltage drop, right? So just keep omega ls into I naught. This is the expected voltage drop with respect to fundamental. So I can write maximum line voltage into cosine of firing angle alpha. That's all. So that is how we are calculating the value of voltage regulation for the 3-phase. So it is very important and it is very easy to see. Just observe this carefully. Omega Ls into I naught. This is simply voltage drop. Voltage regulation is directly proportional to voltage drop only. So voltage drop is what? Omega Ls into I naught. It is already given. In the denominator, see there. VML into cos alpha. Just treat it as the voltage, maximum voltage. That's also maximum line voltage. So with respect to total voltage, we are keeping the voltage drop. This is simply called voltage regulation. It's over now. Now you can expand this. Omega can be written as 2 pi f into Ls into output current I naught. In the denominator, I can consider it as maximum line voltage into cosine of alpha. When there will be no any information about alpha, you can treat this value of cos alpha equal to 1, such that voltage regulation will be maximized. So here they haven't given any information about the alpha. If you notice the question, firing angle information is not given. So you can leave it as it is, not an issue. And they clearly told that at the secondary side we are receiving only 440 RMS voltage. But what we need? Anyway, always in the question they will be giving you RMS line voltage only. But I need line voltage only, but maximum voltage. How will you calculate maximum? So given it is RMS line voltage, I need maximum line voltage. If RMS line voltage is 440 volt, then the maximum line voltage can be written as maximum voltage equal to root 2 times of RMS line voltage. Yes or no? Such that from this I can write maximum line voltage can be written as root 2 into 440 voltage. We got this answer. Now substitute it here into this expression. Okay, sir. And the next thing is this 2 pi omega ls. We can also write it in this way, but it is all put together. If you observe, it can be written as omega into ls. This omega into ls is nothing but XL. I am just considering the magnitude of the inductive reactance XL into output current I naught. Sir, why are you writing in this way? Because only inductive reactance is given to us. That too in percentage we are converting into per unit value. So let us see how do I substitute this value. XL into I naught divided by maximum line voltage. Just now we found it will be root 2 into 440, and as I told you that replace the value of cos alpha by 1 when there will be no any information about alpha. So the inductive reactance I can write 0.06 because given it is 6 percentage. If you want to know the if you want to write the actual per unit value, then you will have to divide it by 100 such that it will give you 0.06. Next, what is the value of output current? That is also given as 150 ampere. Just to note down, observe the question. This data is already given, so it is 150 ampere. Now if you reduce this expression 150 into 0.06, what you will be getting? It will be, I can directly say, if I multiply, it will be 1.5 times of 6. It will be 9. In the numerator, you will be getting 9. In the denominator, we have root 2 into 440. So we will be getting 622 upon 25. Now take the reciprocal for this value and multiply it by 9. We will be getting 0.0144. Suppose if we were requested to keep this value in percentage. In your question, they were simply asked you to keep the value of voltage regulation. If you want to keep this answer in percentage, multiply it by 100. So such that voltage regulation will be converted into percentage. If I multiply it by 100, it will give you 1.44 percentage. This is the voltage drop. Now you can just remember this formula. This is for 3-phase 3-pulse converter. Okay, that is enough. Okay guys, so let's moving on to the next question. Don't memorize too much, just observe what is the definition for voltage regulation. Voltage drop upon total voltage. That's all. So here we are keeping in the same way. Total maximum expected voltage in the denominator. Numerator, this is voltage drop formula only. XL into I naught. According to Ohm's law, V is equal to I into XL is nothing but what? Voltage drop only. Right? Okay, sir. That's all. So that is how we are estimating the voltage drop. voltage regulation. So while solving the problem, as I told you, keep smile in your face. Don't be serious. We are not doing any operation. Okay. Now the next question. A DC battery. Let us take a beautiful DC battery. A DC battery is charged through a resistor. A DC battery is charged through a DC battery is charged through a resistor R. Okay, so it will be shown in the figure. The SCR is fired continuously. Next, the SCR is fired continuously. The SCR is fired continuously. That is the one more statement is given. Whereas they have given the supply voltage Vs equal to 200 voltage, comma, battery voltage E in the output side, it is given as 150 voltage, and the value of resistance R is given as 10 ohm. That is the given data about supply voltage, battery, everything. Now the question is, the battery charging current is dash. The battery charging current is dash. That is the question. They have given the diagram. I am just showing it to you. Given it is, there is one sinusoidal source. It is connected with our thyristor, and then you can observe it is directly connected with the RE load. There is one resistor and one battery. This is the given data, given circuit. Whereas all the data were given about supply voltage and battery and the value of resistor, everything is given. Now the question is just to figure out the charging current. You will be requested to take 2 to 3 minutes. Take 2 to 3 minutes. Drop your answer in the comment section. Do it fast. How will you find out the charging current of the battery? I am waiting for your answer. Apply your basic knowledge. What can be the expected answer for this question? Use your basic things. When RE load is given, how to draw the waveform pattern, how to calculate the average current. I am requesting you all to watch the lecture properly. I have already requested many times. Don't blindly follow anything, because observing the operation is very important. At least some basic knowledge is required, not fully, some basic. If the variety of loads are connected, how to draw the waveform for different load, same pattern will get repeated. If you learn for single phase half wave rectifier, if you learn how to draw the waveform for R load, RE load, RLE load, then RL load, same pattern will get repeated for all other type of rectifiers. It will become very easy. Just that waveform pattern will change. But once you understood how to analyze these things, then the way of deriving the things will become same. It's similar. So it is very easy. This subject is very easy subject. The only problem is, if you are not aware of how to draw the waveforms, it will be a little problem. That is where you will be struggling. Rest of things will be fine. That is the only thing that what you want to know. Anybody got the answer? Do as fast as possible and drop it in the comment section. That's what I want. I'm just expecting and waiting for your people. Waiting for you people only. You can take 1 or 2 minutes more also. I'll be waiting, no issues. But try and bring the answer because it's very small question. A single phase half wave rectifier is given with RE load and they're simply asking what is the charging current, average current through the output circuit. That's all. Nothing else to learn apart from this, learn from here. Anybody got the answer? Okay. Sure. Okay, guys, listen. It's a single phase. Good. Dinesh, 5 ampere. Very good. Any other people? Okay, you people are trying, right? I'm very happy with that. You can drop your hands. I will give 1 more minute then. You can try and drop your answer further. Manivannan 5 ampere. Very good. Kalaivani 5 ampere. I'm very happy to see your answers. Okay, good. See, basically, you all know how to draw the waveform for this circuit. Whenever the waveform is given, always, if you observe, if your circuit is implemented with the battery, whenever you are observing the battery, it is very important to observe its pattern carefully. What you have to do? First, you must take input supply. Your input supply will be acting as a anode voltage and your battery voltage will be usually acting as a cathode voltage. Now it is very important to observe these two patterns. So what you have to do, take the battery voltage and treat it, place it at a proper position. We know the maximum value of the supply voltage. What is the maximum value of the sinusoidal voltage? Given it is RMS voltage, it is 200. Maximum voltage means 200 into root 2. So the maximum value of the supply is 200 into root 2. Whereas battery voltage is clearly given as 150. So it will be somewhere here. There will be no any data about firing angle. It means they told that your thyristor is continuously fired. Continuously fired in the sense we are not applying pulse. With respect to time period, gate current is continuously applied in this manner. So you can make the value of alpha equal to 0. Already one condition is satisfied to turn on the thyristor that the gate current is not equal to 0. Usually, in many of the previous cases we observed, VA become greater than VK first. Gate current will be injected later. But in this case, already they were injected the gate current. Now we have to check when the value of VA will become greater than VK. You have to identify this position. Once your circuit satisfies this condition, then thyristor will turn on because it is already accepting the gate current. It is ready to turn on. Now, if you observe, as I told you, that sinusoidal waveform will be acting as here. This is anode voltage, sinusoidal waveform. This is cathode voltage. Let us start the operation at 0. If you observe at 0 degree, sinusoidal voltage is 0, DC voltage, that is anode voltage is 0, cathode voltage is 150. Cathode voltage is fixed. Then when our circuit will turn on, when anode voltage will become greater than cathode voltage. Cathode voltage is 150, anode voltage will become greater than 150 only when it is crossing this point. Yes or no? So I can call this point as theta 1. only at this point, what will happen when our circuit is crossing this point, that is the point where our thyristor will going to be triggered. At this point we can say the supply voltage Vm into sine omega t will be replaced by theta 1. Vm into sine theta 1 will be equal to battery voltage. Yes or no? See, both are meeting at the same point. After that, sinusoidal waveform is continuously increasing, whereas battery is constant. See there, sinusoidal waveform is continuously increasing after that, whereas battery voltage is fixed. So let us see, this is considered as the firing angle. When firing angle alpha is not given, then we have to check this condition. Okay, firing angle is already given, that is 0. But the second condition, when VA will become greater than VK, that to happen when Vm sin theta 1 will be equal to E. From this I can say theta 1 is equal to sine inverse of E upon Vm. That is the point when thyristor will turn on. Now the value of E is already given, that is 150 voltage. Value of maximum supply voltage is equal to 200 into square root of 2. Now if you take the ratio between 250 upon 200 upon square root of 2, you will be getting 0.3, 0.53. Okay, sir. Now I am just taking sine inverse. The value of theta 1 will be equal to 32 degree approximately. Okay, sir. Then what will happen? Thyristor will be turn on exactly at theta 1. After that, it will be acting as a short circuit. Under this portion, it will be acting as a short circuit. So thyristor turn on means ideally it will be acting as a short circuit. Sir, up to which portion this thyristor conduction will be continuous? Let us see. This thyristor will be continuously conducting till this condition is valid, till VA became greater than VK. Observe this, sinusoidal pattern is initially increasing and it is reaching maximum value of 200 into root 2. Again it is started decreasing, decreasing, decreasing. See there, exactly at one more point, I am calling this point is theta 2. After theta 2, sinusoidal waveform is started decreasing. So here once again the condition will become invalid. Invalid in the sense the value of Vk will become greater than the value of Va. Now this is Va. See that all the values of Va, all values of Va are going to be less than the value of Vk. So thyristor will be intentionally forced to turn off. So it will be again up to next 360 degree. If you observe, this cathode voltage is greater than all this negative value of negative and positive value of the sinusoidal waveform. So for the rest of whole period, thyristor will be remaining off. So the conduction period of the thyristor is only from theta 1 to theta 2. Sir, how will I explore the value of theta 2? We know how to calculate the value of theta 1. See, it is very easy. Why? Because from 0 degree to what is the expected value of theta 1? It is 32 degree. Same way, in the opposite side, from 180 degree to theta 2 will be placed at the same position. From left to, from 0 to, we will be crossing 32 degree. Then to obtain the theta 2, what you have to do is total degree from 0 to 180. Go up to 180 degree, go up to 180 in order to achieve the theta 2. Theta 2 means I just wanted from 0 what is the value of theta 2. For that, theta 2 equal to 180 degree minus just subtract theta 1, because from 0 to theta 1 whatever the distance that we are observing, same distance you can observe in the opposite. Opposite means what, sir? See, let me tell you, show you separately. Suppose from 0 to theta 1, this is the distance. Same distance you can expect from 180 degree into opposite direction up to theta 2. So what you can do is, I just wanted to know from 0 to theta 2. I am telling that in between 180 to theta 2, we will have same distance, theta 1 only. So now in order to achieve, this is the theta 2 now. In order to achieve the value of theta 2, take the whole value. Whole value is what? 180. From 180, subtract theta 1 such that you will be getting theta 2. That's all. So here theta 2 just now we have been estimated, that is 32 degree. So it will be, if you subtract 30 from 180, it will be 150. Again if you subtract 2, it will be 148 degree. We found the value of theta 2 also. Yes, sir. Now it's time to draw the waveform pattern for the current. We found that thyristor will be in conduction only from theta 1 to theta 2. What about the remaining portion, sir? So I can say If you observe from 0 to theta 1, thyristor is off. Off means what? I can directly write that is open circuit. Then from theta 1 to theta 2, thyristor is on. On means what? Again it is short circuit. Again I can write from theta 2 to 360 degree up to 360 complete cycle, thyristor is off only. Because condition is once again what? Not satisfied. So once again it is open circuit. Now tell me when you can observe the current flow in the given circuit. See, if you observe in the given circuit, supply voltage, thyristor, all the people are connected in series. So in a series circuit, if any one element is behaving as a open circuit, what will happen? Whenever your thyristor is behaving as a open circuit, it means open circuit in the sense your circuit will be offering infinite resistor. When the resistance is approaching infinity, current will be approaching to 0 ampere. We all know this fundamental basic. I can say, so whenever thyristor is acting as a open circuit, current flow through the circuit will become 0. So the current flow, you can observe the pattern, current flow will appear. You can observe the current flow through the circuit whenever your thyristor will turn on. Thyristor, when thyristor will turn on? Only between the period of theta 1 to theta 2. See that? This is the portion where thyristor they turn on. So I can say only in this period you can observe the current in the output side. In the remaining all portion current will be 0. Okay, sir. Now how will you draw the current waveform? See, first I will tell you what is the value of the current. Once your thyristor is turned on, then if you redraw the circuit, you will have a sinusoidal waveform. Again, start from this supply. Supply is connected with your thyristor, but thyristor is going to act as a short circuited one. Then in the output portal you can observe resistor, you will be having battery voltage. That's all. Yes or no? Now see that this is the terminal, whole terminal where we are trying to observe the total output voltage V0, and this is resistor R, and this is E. This is supply voltage Vs. And if you carefully observe, we are in first half cycle. Thyristor will be in conduction only positive half cycle, I can say. So now if you observe, this positive voltage will be directly reflected at this port, and this negative voltage will be directly reflected at this port. So I can say output voltage V0 is directly following the value of supply voltage between theta 1 to theta 2. That is the point where thyristor will turn on. So I can say V0 equal to Vs, first conclusion. Vs can be written in terms of instantaneous voltage. It can be written as Vm sin omega t. So that is the output voltage V0. The alternative way to write down the expression, we can treat this one as output expression, equation number 1. The alternative way is current flow through the circuit is I0. Guys, do you know why I am deriving this? It is RE load. Yesterday also we have been solved on question with respect to RE load. It is very important to know that. That's why I'm one more time I'm proving how to do these things. But in future, don't expect all these things from my side. It's my responsibility to train you. It is your responsibility to train yourself. Then only you will be getting all day rank. So be aware of it. Okay. See there. The current is whatever. Directly I'm putting output current because all the elements are connected in series. Output current, supply current, thyristor current, everything will be same here. Output current will be going like this. Now for the resistor, current entering point plus leaving point is minus, and the voltage drop across the resistor can be written as V is equal to I into R. Now if you apply KVL for the outer loop, we can write the output expression can be like this: minus V0 plus voltage drop across the resistor I0 into R plus battery voltage E equal to 0. Can I write like this? Just apply KVL. I have started from here, minus V0, then plus I0 into R, once again plus E0 equal to 0. From this, output expression V0 can also be written in the alternative way, that is E plus I0 into R. Treat this one as your equation number 2. Now just equate your equation number 1 with the equation number 2. When you equate these two, from this you will be getting the expression for C. Vm sin omega t will become equal to the value of E plus I0 into R. Try to explore the value of I0 from this. If you are expressing, keep I0 one side, pass E to the left hand side such that it will become Vm sin omega t minus E pass the resistor to the right side, it will become lies in the denominator. This is the expression. This is how we are writing the expression for output current I naught. That is how we are drawing the waveform for output current I naught. So what we understood here, in each and every point you have to subtract the value of Vm sin omega t and the battery voltage E in order to draw the output current. It is very important. That is the next thing that we have observed here. Okay, sir, we understood this. Now let us see. We understood that supply voltage and the battery need to be subtracted to draw the output waveform current. Vm sin omega t minus E is considered as output current. We should divide it by R. Yes, that is correct. Right? Fine, sir. Now let me remove some other stories here because now I know you all understood this. That is 148. Yes. It's time to explore all other things. Okay. Can you draw the output current now? Do it by yourself because I told everything. Sorry. Yes, so this is our waveform. Shall we start? Yes, sir. What we understood here is one thing. The output current will be zero when thyristor is turned off. That's all. Now, when I am trying to draw the output current, it will appear only when omega t will lies between theta 1 and theta 2. Only at this portion thyristor will turn on. Now let us start how to draw the current waveform here. Carefully listen because in some cases directly you will be requested to identify the waveform, current waveform. Current waveform will come. See, from 0 to theta 1 current value is 0. Why? Thyristor is open circuit. From theta 2 to 360 degree current will be 0. Why? Thyristor is open circuit. So current will appear only from theta 1 to theta 2. How will you find out that? Just now I wrote that the value of I naught is nothing but the subtraction. I have to subtract Vm sin omega t. That is our sinusoidal waveform minus E. Then you can divide it by R. Just the factor R will reduce the value of current a little much. That's all. Now let us start. Vm sin omega t minus E. We are going to start from theta 1. At theta 1, if you observe, Vm sin omega t and E both will become equal. When both are equal, what will happen? The value of output current will be 0 ampere. So it is started at a 0 ampere. After that, the value of Vm sin omega t is slowly increasing. So let us take some values. We know both are 150 at this point. Both are equal to 150. Now let us take input. Vm sin omega t will become equal to 180. Let us assume. It is going up to 200 into root 2. So I am just taking 180. If it will become 180, then 180 minus 150 will give you 30. 30 by R. It means current value also slowly increasing. At this point, when Vm sin omega t will be reaching maximum value, so Vm sin omega t, that is maximum minus 150. Current value also will be reaching its maximum value at this point. Current also will be reaching maximum value. After that, Vm sin omega t is decreasing, so current value also decreasing. One more time, when theta 2, when we are reaching theta 2, once again Vm sin omega t and E both will become equal, so current value will become once again 0. So this is the only period. That's why it is very easy to calculate the value of I naught average whenever RLE or RE load is given. Because if you draw the waveform for voltage, voltage will be existing from 0 to 360 degree. Now you can draw the V naught average and then try to calculate the value of V naught average. Then you will be understanding that why we people are calculating I naught average directly, and then from that we are calculating V naught average in case of RE and RLE load. Whenever RE and RLE load will be given, even in textbook also you can find people will be directly calculating I naught average instead of calculating V naught average. The reason is steps will be very simple. See, current is existing only from theta 1 to theta 2 for the whole duration of 360 degree. Whereas if you draw the pattern for voltage, it will exist from 0 to 360 degree. In that case, the derivation will become lengthy. Instead of doing it that way, first explore the value of current. Then from the current, we can easily calculate the value of V naught. How? V naught equal to, just now I have wrote the relation. See there. V naught equal to E plus I naught into R. If you calculate the value of I naught average, just multiplying it by R and adding battery voltage, you can easily explore the value of V naught average. It is very easy. That's why we are always supposed to calculate I naught average whenever we are having RE or RLE load. Can you explore the current now? Yes, sir. So finally, output current I naught out of the total period 1 by 2 pi, that is 360 degree, we will be receiving the current only from theta 1 to theta 2. You can convert it into equivalent radiant value if you want. Please do it by yourself. And here I am going to substitute I naught average with respect to d omega t. And we know the expression for I naught. What is the expression? The value of I naught Vm sin omega t minus E by R. Now let me replace this, right? So here we are going to substitute. Actually, we are calculating I naught average here. Don't substitute here. Now substitute the expression for I naught. So let me substitute it. So we can say I naught average. Hereafter you know how to do. Anyway, I'm just showing it. Theta 1 to theta 2. I naught can be replaced by Vm sin omega t minus battery voltage E upon R with respect to d omega t. Now if you reduce this expression, 1 upon 2 pi, R is constant, you can take it out. Now if you integrate sin omega t, that will give you minus cos omega t minus battery voltage E is constant with respect to d omega t, then d omega t will be converted to omega t. So constant with respect to d omega t integration will give you the value of omega t only. Now for the whole limit, we have to substitute the value of theta 1 and theta 2. Let us substitute. From this I can write it will be 1 upon 2 pi r in bracket. Now I can write Vm into minus upper limit cos of theta 2 minus of minus lower limit will become plus, because lower limit will give you one more minus, so it will become cos theta 1 cos theta 2. One case minus of E into here upper limit is theta 2 minus lower limit is theta 1. That's all. Close everything. So here you know where we have to substitute the value in degree, where we have to substitute the value in radiant. Minus cos of, I think theta 2 is 148 degree, we have estimated, right? Plus cos of theta 1 is 32 degree approximately, we have calculated, minus E into here I'm just multiplying. See, we know this is 148 degree minus, once again I'm subtracting 30 degree, but sir it is in degree. I'm converting this value into radian. For that I'm multiplying it by pi by 180, such that it will become very easy for us now. Now if you subtract 148 minus 30, what you'll be getting? You'll be getting 118. So 116 degree, 116 degree into pi by 180. So 138 minus 32, you will be getting 116 degree into pi divided by 180. So you'll be coming up with the 2.02, this whole value. I'm getting 2.0245. And then the value of battery voltage is 150, right? I think I am remembering. Yeah, it is 150. Substitute it. So it is 150. So we have to multiply it by 150 such that it will give you the overall value including battery. The total value here I am getting 303.687. Okay, this is one portion. Second portion. Now what is the equivalent value? Cos 32. First to calculate cos 32, we are getting 0.848 here, 0.848. Again 148 we should take cos, then already there is one minus. Cos of 148 will give you minus 0.848. So minus into minus will be plus. With this we have to add once again one more 0.848. So directly we can multiply it by 2. So we'll be getting 1 point. So this total value will become 1.696. Maximum voltage, we know it will be 200 into root 2. Now let's time to multiply it. Multiply it by root 2 into 200. You will be getting 479.72. The overall value will be 479.728. Now we have to subtract both values. See, 479.728 minus 303.6872. We will be getting 176.041. So finally 176.041 upon 2 pi into, what is the value of R? I think it is 10. If I divide it by 10, that will be 17.60 ohm. So now I am dividing it by 10, I am dividing it by 2, I am dividing it by pi. So we'll be getting 2.8 ampere only. 2.80 ampere. How many of you got this answer? Tell me now. Some of you dropped your answer as 5 ampere, right? Maybe your answer is correct. I'm not giving a surety. ஏதாச்சும் நம்ம mistake பண்ணிருந்தோம் அப்படினா you can correct it. But this is the answer I got, 2.8 ampere. So this is how we are solving the problem. See, I can't do in the same way for every questions. But it is your responsibility to explore in a proper way. When you are doing multiple number of questions, after a particular time period, everything will be reserved in your brain, so you can take whatever that you want. Chalo. Take the next question. Given it is a single phase full bridge rectifier is feeding RE load. This is not RLE load. It is feeding RE load. And a trigger pulse is applied continuously. As usual, they are applying trigger pulse continuously. Trigger pulse continuously applied. And they told the value of resistor is once again given as 10 ohm, and the value of battery voltage RE, right? So it is 100 voltage, it is given. And they told supply voltage Vs equal to 120 as usual. Supply voltage is 120. Now the question is, what is the average value of the output current? Nice question, right? Average value of the output current is dash. So it is full bridge rectifier. Previously we were solved off bridge rectifier. Now it's time to explore full bridge rectifier. At least I am expecting the correct answer now. I'm really very happy to seeing this question, because last question we were explored for half wave rectifier. Now same question we are exploring it for full wave rectifier. Take your time, try to drop the correct answer. All I wanted to expecting from your side is just the correct way of approaching. Just now I had given the way how to approach. Now draw the full wave rectifier. Already you might having the expressions directly. If you are having, you can directly write the formula and try to bring the answer. Take your time. Up to that point, I will be deriving myself. I just wanted to know the answer for I not average. As usual, we have to consider the overall time period. The resistor will come out. I am doing it by myself. Don't focus here. Do it by yourself. So we have to substitute theta 1. Firing angle is as usual continuously applied, so alpha will become yes. So, but it is time to explore the value of theta 1. And theta 2. So theta 2 can be replaced by pi minus theta 1. Guys, you can also compress the expression. Theta 2 you can replace it by pi minus theta 1. Right, such that everything can be written in terms of theta 1. You can do it that way also. If I will write like this, then it will be twice of theta 1. Then it will become 2 times of Vm into here theta 1 pi minus theta 2. Minus into minus will be giving you pi minus 2 times of theta. See, I have explored one value here. It is full wave. This 2 will not come. Okay. You can cross check. I wrote the formula by myself now. If there is any mistake, you can correct it. Now substitute all the values. This is the expression for I naught average in case of full wave rectifier. It will be 1 by pi r 2 Vm cos theta minus E into pi minus 2 theta. Did you observe one thing? While solving the problem, this is the thing that you have to notice. Whenever they are talking about R load, RL load, you will be requested to calculate the value of V naught average, because derivation of V naught average is very easy in case of R load and RL load. In the examination point of view, time consumption is very less. If you observe RE load or RLE load, you will be requested to calculate the I naught average, because deriving I naught average is very simple in case of RE load, battery connected load, battery type of load. So they will be asking you to calculate the value of I naught average. So that too you should recognize these things. Okay. So it is very important. If you remember the expression for V naught average in case of R and RLE load, and I naught average expression for RE and RLE load, you can easily simply get the answer. And one more thing what you can understand from here is, if you know V naught average, we can easily calculate I naught average, because I naught average equal to V naught average by R. Similarly, in case of RE load, if you know I naught average, it is very easy to calculate the value of V naught average, because V naught average equal to E plus I naught into R. So it doesn't matter which expression you are keeping in your mind, and I am not intentionally forcing you to memorize. But in the examination point of view, to save your time, see, if you want to get all India rank, you can store something in your mind. Our brain is having the ability to store millions of books. People are telling it is not even 0.00001 percentage. So you can try it. Nothing is wrong here. Gita 0.796 ampere. Very good. Any other answer? I got answer from one of your. Any other? Anyway, everything is available directly here while substituting pi minus 2 dot t. Do remember theta pi minus twice of theta. You have to substitute the expression. See, this is theta 1, not theta. Forgive me. What I did is I have replaced theta 2 by pi minus theta 1. You can do in that way also, such that the expression will be simplified. You should substitute the value in radian here. How will you do that? Multiply it by pi by 180 degree. That's all. It will be converted into radian. Then you will be getting the correct answer. Okay, I'm going to the next question, because there is nothing to evaluate from here. I have explored the formula. The required one is given. You can try it by yourself. Let us go ahead with the next question. See, the next question is, let us take a battery. A battery with a terminal voltage. A battery with a terminal voltage. A battery with a terminal voltage of 100 volt. A battery with a terminal voltage of 100 volt is supplied a power. Guys, 1 minute. Please stop this, because it is chapter 11 question. We will be solving in the next chapter. I haven't noticed fully. Skip this question. Let me drop the next one. A single phase full bridge converter. A single phase full bridge converter. Full bridge converter feeding. A single phase full bridge converter feeding RLE load. Feeding RLE load has the following data. RLE load has the following data. Has the following data. So the data is given as supply voltage. They told that is 220 voltage, and frequency is given as 50 hertz. We can take, and resistor value is given as 5 ohm, and battery voltage E is given as 150 voltage. Everything is given now. Firing angle alpha also given as 45 degree. Then what is the question, sir? Output current is ripple free. I not, you know the meaning of ripple free. We have explored this already. Output current is ripple free. Now the question is the load power factor will be dash. Load power factor will be dash. Can you please figure it out? Everything I have given, all the data is available in the question. The simple question is, what is the load power factor? Try and drop your answer in the comment section. Take 2 to 3 minutes. I will be waiting for you guys. Nothing to worry, just to calculate the power factor. Cos pi, we are trying to explore the value of power factor offered by the circuit. That's all. Do something to explore the value of power factor. Output load level of power factor வரும்னு கேட்டிருக்காங்க. See, it's a beautiful question. One thing what you should remember is question examல எந்த ஒரு எக்ஸாம்லயும் question டீப்பா கேட்க மாட்டாங்க. But they will give some twist. You should play it like a game. Wow, it's a beautiful level. You are in the next level. While going to solve some question which is not known to you, you should treat it like a we are in the next level. It is little bit different than what we think in the last in the previous problems. So now it's time to explore your knowledge. Okay, it is completely given. RLE load is given. How to draw the output pattern, how to calculate the output power. What are the possibilities are there to calculate the output power? You know, output power in case of RE and RLE load can be calculated in two ways. How, sir? Because we saw output voltage can be directly written in terms of supply voltage. I have explored, right? You might be remembering in the last question when I was this one only. Just observe this. What we saw, output voltage can be expressed directly as Vm sin omega t. It can also be expressed in the alternative way, E plus I naught into R. This is for RE load, right? Yeah, this load is RE load. So RE and RLE load. In case of RE and RLE load, output expression can be written in two ways. If output expression can be written in two ways, is there any possibility to write output power also in two ways? Then from that you should think, because they are talking about load power factor, cos phi, output power factor. How do I explore with the help of, you know how to write down the real power? You know the formula to calculate the real power. Now it is time to explore it in two ways. I had given the clue now at least. Sufficient things I have given. Try it by yourself. I am expecting the answer from your side. Do it. Do it. You can. Definitely you guys can do it. Got the answer? Take 2 more minutes also. I'll be waiting. Simply think and try to explore. Learn everything in a proper way. Definitely you'll be getting all India rank. Don't keep any other things in your mind. So during the class, just observe how we are doing the problem and understand the subject in a proper way. When there will be no class, try to solve as many questions as possible, but just to keep one thing in your mind. Don't follow the solution of anyone. It should be your own. Because if you want to get all India rank, it should be your own idea. Then it should be your own idea. That is very important. So try to explore whatever the thing that you are willing to explore by yourself. You have to do it. Okay. Anyone got the answer? I'm expecting it to be in the comment section. Chalo. Let me try to solve this question. What I understood is, see, listen guys. Anyway, it is single phase full bridge rectifier. You know how to draw the rectifier circuits at all. I am directly keeping our attention with the output. Given it is RLE load, it is RLE load or RE load. We know we are not going to consider the effect of inductance to calculate the output current because it is connected with a constant battery. It will be behaving as a short circuit. You cannot see its effect. So your output will be simply having only resistor and a battery, and your output current will be going in this way, and you all know current entering point plus leaving point is minus. The overall output voltage can be measured between these two terminals. I can say this is the point where we are going to measure the value of output. You also know this output expression can be written in two ways. So V naught equal to, the first way is in terms of supply voltage, I can call it as Vm sin omega t. Second, what we can do is it can also be expressed. This V naught can also be expressed in terms of what? See, if you apply KVL for the output circuit, you will be getting, if I will apply KVL for this network, Kirchhoff voltage law, you can start. This is minus V naught. Yes, sir. Or otherwise, you can say supply voltage V naught equal to minus V naught equal to plus I naught into R. Starting polarity is plus I naught into R plus E. From this I can say V naught equal to, it can also be explored in terms of I naught into R plus battery voltage E. So there are two ways. So this is how we are writing the expression for output current and voltage. Yes sir, of course we are correct. Now from this expression I can write down the expression for I naught. So I naught can be explored like this, V naught minus E upon R. In this way, we can explore the value of I naught, and this V naught can be replaced by Vm sin omega t. It depends on the situation. Okay, because in this circuit I have some other idea. I'm not substituting Vm sin omega t. I will tell you because some key they have given already. Fine, sir. So this is how we are exploring the value of I naught. Sir, you told that there are two ways to explore the value of output power. How do I do that? See, let me help you to do that. If you take this second expression multiplied by output current I naught, what you will be getting? This output current V naught into I naught, it will be simply giving you, if I multiply by I naught, then in the left hand side it will become I naught square into R E into I naught. Now if you observe I naught square into R, this is the power consumed by the resistor. E into I naught, this is the power consumed by the battery. So in the output side, we have only two loads who will be consuming real power. Don't think about the inductor. Inductor will not consume any real power. It will consume only reactive power. In this case, I am talking about real power. So you don't need to be bothered about whether the inductor will take consume real power or not. It should not be. உங்க மைண்ட்ல அந்த மாதிரி ஒரு கொஸ்டின் வரவே கூடாது. Okay. Okay, sir. So in the output side, we will be having only two elements. One is resistor, another one is battery. So if from this I can say this is the alternative way to write down the output power. See, this is the total output power consumed by the load. In the right hand side, I cannot simply keep I naught into V naught. I have to multiply this factor I naught by one more term that is called cos phi. Why, sir? Why? Because you cannot simply write down this I naught into V naught by P naught. It should not be correct. Why? Because in the output side we will be having RLE load. Your power factor should not be 1. We will be having reactive power plus real power. Anyway, we are in a rectification process. Due to this, you will be observing harmonics in our circuit. So definitely you can observe the presence of reactive power. Your power factor should not be 1 at any cost. Okay, sir, fine. So what you have to do is you will have to consider the effect of output power can be expressed in two ways. One is directly by considering output voltage and output current and the cosine of phase angle difference between these two people. The alternative way to explore this value is You can also see this is the power delivered to the load, total power. In terms of source, I am doing this. In terms of load element also, we can write I naught square into R, power consumed by the resistor, plus I naught into E, power consumed by the battery. Both will give you the same answer. Now if you equate these two expression, what you will be getting? Let me do it. I am just equating them. So from this I understood that V naught I naught into cos phi can be explored I naught square into R plus E into I naught. From this I can say the value of cos phi equal to I naught square into R by V naught I naught plus E into I naught by V naught I naught. See there, one I naught will be cancelled here, one I naught will be cancelled here also. I can write I naught by V naught into R plus this will be going to be E by V naught. What you understood here, from here I can say if I know the value of I naught R plus E upon V naught, that will be giving us the value of power factor cos phi. This is what we understood here. We can write it in this way. Okay, sir. Now it's time to explore everything. How do I calculate the value of V naught? Directly. See, given it is single phase full bridge rectifier, the direct formula to explore the value is 2Vm by pi cos alpha. Sir, how can you write this expression? For a RF or the RLE load, you told the derivation is continuous. Yes, derivation is big. Yes, of course, everything is fine. But what they given is, the key is given that the value of output current is ripple free. When the output current is continuous, I hope you all have remember what I told you. It doesn't matter what type of load that you people are keeping. If they told that the output load is continuous, output current is continuous, then you have to go up with the generalized expression. Now if you observe here, maximum voltage is given, cosine alpha is given, supply voltage is given as 220. From this maximum voltage will be root 2 times of 220. Then alpha value is given. From this you can explore the value of cos alpha. So I can write 2 into root 2 into 220 upon pi into cosine of 45 degree. So we can explore the value of V naught from here. Yes, sir. So if you do it, 2 into 220 will give you the value of what? 440. Cos 45 will be equal to what? Cos 45 will be equal to 1 by root 2. So root 2, 1 by root 2 will get cancelled out. So you will be coming up with the 440 by pi. Now if you explore the value of 440 by pi, you will be getting 140. It will be equal to 140.056 voltage. We found the value of expression of V naught. Okay, sir. To know the value of cos phi, battery voltage is already known, resistor value is already known. Now V naught value also known. What about the expression for I naught? You know how to explore the value of I naught. I naught equal to V naught minus battery voltage E by resistance R. So the value of E naught just now, it will be 180.056 minus the value of battery voltage is how much? Is it 150? Yeah. See, battery voltage is 150. I think battery is delivering the power. See, do one thing. I think they did some mistake here. Increase the value of battery voltage. Make it 180. Not okay. Already it is 150. Keep it 150. Raise the value of supply. Let me make it 250 voltage. Because it should not be. They made some mistake. இந்த மாதிரி क्वेश्चन எடுக்க கூடாது. I know, right? Power consumption இல்லையா, power factor. It should not be. Make it 250. That is some mistake, I think. 250 போட்டீங்கன்னா என்ன வரும்? 2 times of 250 will give you 500. So let me take 500 by pi. I will be getting 159. Guys, the data is wrong. Because otherwise the direction of current will get reversed. Anyway, you know, in that case also you know how to explore. It's better to go in this way. You'll be getting complete idea. Battery voltage 150, output expression is 159.15. Don't be bothered. Suppose இப்போ நம்ம எடுத்த டேட்டாவே क्वेश्चनல கொடுத்திருந்தாங்கன்னா you just continue with that. You will be getting negative value, that's all. Just consider the magnitude and substitute. You know what I told you, when battery voltage is greater than V naught, then reverse the direction of the current. Right? E minus V naught by R. That's all. Don't think too much. Okay, sir. Now what will happen? Here 159 minus 150 will give you 9.15 divided by what is cell of resistor? Is it 5 ohm? Yes, it is 5 ohm. Yes, it is 5 ohm. Now you can cancel it. Minus 150 divided by, we have to divide it by 5. So I am getting 1.83 ampere. But this is not the answer. Let us substitute everything here. So output current is 1.83 ampere into resistor is 5 plus battery voltage is 150, we already kept. Upon output voltage we got 159.15. So what we will be getting? 1.83 into 5 plus did I made any mistake here? Mm, guys, I did mistake somewhere, but I don't know where I did that. 1 minute. What I did? Guys, listen. One small mistake I did. Here everything is correct, but this current output current is there, right? We should not substitute this current here directly. It will be RMS current, but that too also correct. Both are same because continuous current means I naught RMS and I naught both are same. Did I made any mistake here? Just wait a minute. In this circuit, RMS current and average current both are same. First conclusion. So we can directly substitute that value here. And something went wrong somewhere. Yes, if you substitute these values, you will be getting the same answer. Let me go in that way also. 1.83 square into the value of resistance is 5 ohm plus battery voltage is how much? 150 into output current is 1.83 divided by output voltage, we got 159.15 into output current I naught, that is 1.83. One minute. Guys, did I made any mistake somewhere? I'm struggling here. No, if we add this again, it will give us the same expression only. What happened here? It is 1.83 and it is 5. Okay, I think there is some mistake is happened. Kindly explore it, cross-check it by yourself. Everything is correct from my side, but they have given key answer. That answer I am not getting. It did get is cancelled. I am getting 1. Yeah, because in the numerator and denominator values are coming same. We have approached the same way in both cases. Here we got the same. It is 1 by root 2 500 by pi. Yes, we got this expression then from here. That is correct. I not expression. There is no doubts. Undoubtedly. Then the output expression can also be written in the alternative way. In that way, if I'll substitute this V naught I naught minus E by R. Okay, something went wrong. I don't know where is the mistake. Kindly, this is the procedure to calculate the value of power factor. Okay, you can just remember it. Explore where I did the mistake because my answer is mismatching. Okay, instead of wasting our time, let's go with the next question. Guys, in free time, just to explore this, I did mistake somewhere in the calculation. Just cross check. You'll be getting correct answer. Everything is correct. I haven't did any mistakes, but there is something is mismatching. Just cross check once. Let us go ahead with the next question. See, they have given one power diode here. With the power diode, we will be having inductor and a capacitor. Supply voltage value is given as 150 volt. Now the question is, what is the expected voltage across the capacitor? Anybody? Steady state voltage. The final voltage or steady state voltage across the capacitor is dash. I hope most of you guys know the answer for this question. I am expecting it to be. First to solve this question, they haven't they told some data here. The inductor is initially 1 millihenry and the capacitor is 2 microfarad. It is given already, and initial value of the capacitor you can consider 5 voltage. Now the question is, what is the steady state voltage across the capacitor? Okay, try to drop your answer. Do remember initial voltage is 5. Okay, chalo, you can take it as the homework question, and this is diode, this is not thyristor. Try to explore the answer for this question and identify the mistake in the last question. Nothing is there, a procedure is correct, so don't try to do any confusion here. Just cross check whether everything, do one more time from the beginning. If there will be any numerical mistakes, just re-rectify it, you will be getting the answer. Then drop your answer in the comment section. Okay, so this is all for this lecture. Almost we have been solved so many problems in the rectifier circuits. There are so many questions yet to come. We will be solving a few more questions which are relevant to, basically in the examinations more weightage will be given for full bridge rectifier in 3-phase and in single phase also. So there are few more questions are there, few more models yet to cover. Those things we'll be covering in the upcoming lecture. Meanwhile, what you guys have to do is start a chopper also. If you have already watched the chopper lecture, then there will be no issues. You can directly recapture all the formulas once, plus inverter also, it's better. Directly you can do that too in free time. Don't spend too much of time. I don't think that will take much time, because in chopper there are no huge formulas. It will take some solidly half an hour to 1 hour maximum. You can spend 1 hour. After that, similarly, spend 1 more hour to recapture the concepts of inverter also, and try to learn the basics of pulse width modulation technique. Anyway, I will be covering, don't worry. While solving the problem, I will be bringing PWM technique also. I will be solving the questions, and I will show you how to drag the data, how to apply everything. I will show you, don't be bothered. But it is your responsibility to recapture the concept, okay, such that it is very easy to understand when I am exploring the questions here. So this is all for this lecture.